So this is a video on getting random integers. This is something you need to frequently do, and the key is this function rand, which is defined in standardlib.h, and you just call it like this. It returns an unsigned long, and we just compile and run this silly program. It says that this is a random number, and if you run it again, it says, it keeps regurgitating the same thing, which is not very interesting. The reason is I'm not exactly sure how rand is implemented. I've read some things online that say it's implemented as a linear feedback shift register, which I've made a video on, which you can look at if you care. But it produces a pseudo-random sequence of integers. So it's extremely pseudo-random. It's not suitable if it is linear feedback shift register, and even if it's not really suitable for like cryptographic purposes, because if you know the mechanism and you know a few of the data points, you can start predicting what the so-called next random number is going to be, which is something that you want to be impossible and to depend on some kind of key value or something. But just for making, games and little programs that make dust motes bounce around the screen and other things like that, this is fine. So you need some place to start the sequence of pseudo-random numbers, and so the seed value somehow translates into a starting place. The default seed value is 1. So I've compiled this program and run it again. Now I've seeded the random number generator, but I've seeded it with 1, which is the default seed. If you seed it with 2, then you get a different random number, and in fact you get a completely different sequence of random numbers, which is sort of interesting. But anyway, so it's actually useful when you're debugging a program for the rand function to always return the same sequence of values. By the way, if I call this thing over and over again, it doesn't keep returning 100 or 1.8 billion or whatever number that is. So let's say that I run it again here. So the second time it returns a different number, and so it's outputting a whole random sequence. So if you do seed the random number generator, you only need to seed it once, and the reason is it's not going to keep producing that one value over and over again. What the seed value does is it starts someplace on the pseudo-random number sequence, and then you do get a pseudo-random number sequence. So a common bug or error or mistake or whatever in people's programs is to constantly be reseeding the random number generator. In your program, you should seed the random number generator exactly once. And if we wanted to look at more values, we could look at the pseudo-random string of numbers. So if you do want it to be truly random, then a common trick is to seed the random number generator with epoch time, which we talked about in the previous video. So now every time I run it, I get a different pseudo random number stream of integers, unless I run it twice in the same second. Let's see if I can do that. Yeah, I managed to do it. So that can be a little bit problematic, but probably not if you're not seeding the random number generator twice. But remember, the epoch time is the number of seconds since such and such date in 1970, January 1st, 1970, and so anyway, that's probably not ever going to be relevant. So it's supposed to be uniformly random. It returns a random number between 0 and some rand max value, which might be on this system the maximum value of an unsigned long. I haven't checked. And so any number in its range is supposed to be equally likely, and then you hope that if you frequently you want a random number that's just in a certain range. Like if I want a random number that's between 0 and 100, I can change this to mod 100, and then I get a couple random numbers mod 100. This one is not mod 100. So this will give me random numbers between 0 and 99, so you might want that. Frequently you don't want to use the whole range. It's weird that there are some collisions there. You don't want to use the whole range between 0 and rand max. You just want some random numbers in a certain value. Maybe you want to pick a random element of an array or something like that. So you would hope that those would be uniformly distributed too in that restricted range. And it seems to me that it wouldn't be too hard to prove that if the random number generator really is uniform on its full range, then it would also be uniform on some subrange that comes from using a modulus here. But at any rate, we know that it's not truly it has some statistical similarities to a stream of numbers that would truly be random, but it's not truly random. Still, you would expect it to at least look kind of random. And so I wrote a little code here to make a histogram and see how close the output of the random number generator is to a uniform distribution. So uniform distribution is one in which any outcome is equally likely. So it takes a number of slots here, like let's use 20, and then it's going to take a bunch of samples from the random number generator. So let's tell it to take 2 million samples, and then it makes a little histogram using some asterisks. And so you can see, you can get a feel for how often each number came up, and it does seem pretty much uniform. This is like almost constant here. And maybe, what is that, 2 million? Make it 200 million and see if it gets any flatter. Then there's a question of how flat you would actually expect it to be. If it were too flat, maybe that's not random either, but it does seem like it flattened out a little bit there when you increase the sample size. So it's approximately uniform distribution. And because this making a histogram thing can be useful, I'm going to show off the code there. Maybe we should go through it too. So I allocate enough memory for some array, which is going to be almost like a hash table. So these are all the slots. So I've allocated enough slots for num slots, which in this case is 20. And really I should be freeing this thing at the end too. I have a small memory leak. And then I initialize it all to 0, and I get some counter variables here. And this is the part that actually takes the samples. So this is just num samples times, so in this case 200 million times. Compute a random number, mod it out by the number of slots. That gives you now a number between 0 and 19. And then you increment that slot. So remember, the slots were all initialized to be 0. So what that does is it sort of records the number of times the roulette ball landed in that cell. And now this is just the output stuff. So you take the relative frequency of each slot, and you have to typecast to a float, because remember, otherwise it'll do integer division and you'll get 0 every time. It's like, in integer division, 1 over 3 is 0. You don't want that. You want it to be 0.33333, so you have to use this typecast to float. And to make the output look a little bit better, you want some fixed cell width, so that if you're looking at the 10th cell instead of the 5th cell, it's not shifted over by 1 because there's an extra digit. And so that takes care of that. And then I have some maximum possible number of stars that could happen in any row, and the relative frequency times that gives a certain percentage of 200. And that's what determines the length of these rows. And you just go through and print out that many stars, and then at the end you want a carriage return so that your output doesn't look all goofy. And that's pretty much it. I can't think of anything to say. There are a couple exercises here. I almost did these, but then I thought I would leave them and suggest that you try to write these functions. And of course, a quick Google will give you somebody else's code, but it's a really good exercise. Write a function that returns a random integer that's in a certain range. Let's say a is less than b. Can you write a function that returns a random integer in this range? Another thing you might do is try to write a function that returns a random real number between 0 and 1. Or you could combine these two ideas and try to write a function that returns a random real number in some real range. So those are useful things to be able to do and good exercises. So I suggest you give those a try.